Hello everyone. In this video we are going to discuss another question of variable size sliding window, that is सबसे बड़ा substring जिसमें सिर्फ k unique characters हो, that is the longest substring which contains at most k unique characters. Let's take an example of what I am talking about. Let's suppose you have a string something as this. Let's suppose this is a string and I give you the value of k as 3. So what are the valid substrings in this case? This is a valid substring. This is a valid substring because it has 2 unique characters. This is a valid substring because again it has only 3 unique characters, which is permittable. Again, this is a valid substring since it has only 3 unique characters. The unique characters are A, B and C. Again, this is a valid substring. But once you take substring this, that is from here to here, you can see that the number of valid characters are number of unique characters are 4, A, B, C and D. So yeah, this is not a allowed window. So in this case, what you will do, you will just shift your A over here. But once you shift your A over here, just tell me one thing, that if you see window from here to here, what are the number of unique characters? They are still 4, isn't it? So yeah, you need to shift from here also. So when you come here, if you see this window, it has only 3 unique characters, A, C, D, isn't it? So again, this is a valid window. So yeah, we need to tell the maximum size of the window. Maximum size of window. This is the question. So I hope the question is clear. In the question, we need to say the longest substring which has at most k unique characters. मतलब खाली k unique characters ही हो सकता है at most, उससे कम भी हो सकता है, but at most k. The count of unique characters cannot exceed k. So yeah, how can we solve this? See, whenever you can keep a map for storing the frequency. We are not using a vector of size 26 because the characters can be anything. It is not ABC, like the characters can be plus, characters can be minus, characters can be 1, 2, anything. So yeah, I am not storing it. I cannot use a 26 size vector because I have not told that characters are only lowercase English letters. Characters can be anything. Okay. So yeah, we can use map for this purpose. We can create a map of char comma. We can create map of char comma int, that is for each character we can store the frequency it comes. Okay, and we can store the number of unique characters we have got till now. So for that I can store a count which is initially 0. Now whenever I come to a character, now this you all will be very much familiar with, like how we approach the question. We initialize our I over here, j over here, shift our j till the condition is valid. Once the condition is not valid, we shift our I forward. This is the approach we always follow. So now we will see how we will check the condition. See, whenever you come to a character, what you can do is you can just increase its frequency in the map. Let's suppose a character comes and what you do is MP of that character plus plus, that is this character has come. Now just tell me, now if the frequency of this character is 1, can we say that this is the first time this character has occurred in this window? After you increment the count of this character and the frequency of this character is 1. So can you say that this is the first time this character has come in your window? So in that case, what you will do is you will increase your count. This count is the number of unique characters. Number of unique characters in the window. So yeah, whenever you increase the count and you see that the count is equal to 1, so you can just increment your count. Like when the frequency is equals to 1, you can increment your count. And else, if the frequency is not equals to 1, this means that this character has occurred before also in your window. And in that case, what you can do is, you can just, you will just not increase your count. Now, once the value of count exceeds the maximum permittable value k, that is the number of unique characters allowed is k, and once the value of count exceed that, what you will do is you will shift your I forward Now once you shift your I forward, what you will do? You will simply do, like, you would want to remove the contribution of that ith character, isn't it? So for that you will do MP of char minus minus. Now after doing this, you will check that if the frequency of this character is equals to 0. What does mean? This means that in the remaining window that character is not present. So one of the characters is removed, isn't it? So what you will do in that case, you will just decrement your count. That is, one of the unique character is completely removed from the window. So yeah, let's dry run for this case, and you will get to know what I'm talking about. Let's just write down this string once: ABCAAD.
Sorry.
ABCAAD. Okay. So, and let's suppose we have a string over here CABA, something like this. Okay. So what we can do is, we will initially keep our count, which is initially equals to 0, and we have I over here, J over here, both initialized to 0. So when we come to A, we will just do MP of A plus plus, and just tell me what is the frequency of A after this step. It is 1, isn't it? So it is 1. This means that this is the first time this A has occurred in this window. So we will just increment our count. Okay. Now when we come to B, we will just do MP of B plus plus. Now once we do that, we will see that frequency of B is 1. This means that it is the first time it has occurred in this window. So we will just increment our count to 2. Okay. Now we come to C. Similarly, when we do MP of C plus plus and we check the value of MP of C, it is 1. This means that this is the first time it has come in this window. So we will increment our count to 3. Okay. Now again, when we come to A and we do MP of A plus plus, now just tell me the value of MP of A. It will be equals to 2. Now since it is equals to 2, we can say that this is not the first time it has occurred in this window, isn't it? So we will do nothing with our count. Again, when we come to A, we will increment our MP of A. MP of A becomes 3, and we will say, yeah, this is not the first time it has occurred, so we will do nothing with our count. Now every time when we come from here to here, we will just do answer equals to max of answer comma j minus I plus 1, because we need to return the size of the maximum subarray, isn't it? So this I to j are all valid windows, so we will just store it in our answer and do max with it. Okay. Now once we come to D, we will do MP of D plus plus, and once we do this, we see that the frequency of D is equals to 1. This means that it has occurred first time in this window. So what we will do is, we will increment our count. But once we do this, we can clearly see that this exceeds the maximum permittable value of unique characters, which was 3. So in this case, we need to shift our I forward. Now the question is, I को कहाँ तक shift करें? So we will shift our I till the value of the count of unique characters becomes 3. Now it is 4, isn't it? So we need to make that 3. So what we will do is, when we will move our I. Now we first of all, our I is present in this index. So we will just remove the contribution of A, and the value of MP of A is now equals to 3. So what it will happen, the MP of A will become 2. Okay, and we will shift our I over here. But do we decrement the value of count? No, because still the value of MP of A is equals to 2. This means that in this window we still have 2 A's, and therefore the count of unique characters will not be decremented. Okay. Now we come to B. We do MP of B minus minus. So MP of B was initially 1. So now after minus minus, MP of B from 1, it will become 0. Now when it becomes 0, we can definitely say that B has not occurred more times in this window. Now since B has not occurred more times, so we can say that the count of one of the unique characters will decrease. So the value of this count will become 3, and our I will come over here. After this step, we can see that count is equal to the maximum permittable value, so we will do nothing, and we can say, yeah, this is the valid window. CAAD is a valid window. So yeah, once we follow these steps till J reaches to A, like J can maximum be present over here. So after all these steps, we will get our answer. So I hope the approach is clear. Let's code it down. Okay. Let's take the size of the string as input, and let's take the string as input from the user. Okay. So initialize with your I with 0, J with 0, and answer with 0, because initially the window we have is of 0 size. isn't it? And we have a map which stores the frequency of characters. Okay, so we will run our loop till our j reaches the end. When we come to a character, we will also like keep a count of number of unique characters we have till now. Initially we have count as 0, and we will also take input from the user of the maximum permittable unique characters. Let's take the input in k. Okay, so while j less than n, what we will do, we will just increment our jth character from the string, and we will check that if the frequency of this character is equals 1, this means that this is the first time it has occurred in the window, so the uniqueness of the window will increase by 1. Okay, so once the uniqueness increases, we will check that if the value of count has exceed the maximum number of unique characters. So if this is the case, so what we will do is we will run a while loop shifting our I, and what is the maximum value till I can be like incremented? Till the value of I is less than equals to j, isn't it? Like j के बाहर तो I को नहीं ले जा सकते because we have not taken the contribution of any number of any character after that. So value of I can maximum go up to j. So while I is less than equals to j and the value of count is greater than the maximum permittable value, what we will do is we will just decrement the count of that ith character, and we will check that if MP, like the count of that character, has become equals to 0, this means that it is not present anywhere in the leftover window. So we will just decrement the uniqueness of the window, and after this we will just shift our I. Okay, once we are done with this, we will check that if the count is less than equals to k, that is the number of unique characters are less than equals to k, so we will just store the max in our answer. So answer is max of answer comma j minus I plus 1. At the end of while we will increment our value of j, that is moving to the next character, and once we are done with this, we will just print our answer. Okay, so yeah, let's run this code for some inputs. Let's take the size of string as 9, and let's take the window size, that is maximum number of unique characters, as 3. Okay, let's enter the string as a b c a d a b c. How many characters? 5.9. Okay, so let's run this one. Okay, it's working fine. We got output at 6. Let's try to look at that 6 size window. If we take this window, it has 5 characters. Okay, we are getting 6. So if we take this, again it is not a valid window. But if we take if we take this window, if I try to if you take this window, it has 3 unique characters and the size of this window is 6, isn't it? So yeah, you got 6 as your answer, which is the correct answer. So yeah, this is the approach. I hope you all are now very much comfortable with sliding window. We have talked about 2 types of sliding window, the fixed size sliding window and the variable size sliding window. And yes, now we will just solve 2 to 3 very good questions of sliding window, and then we will be done with it. So by then, thank you, keep watching.